Hi, how you doing? It's Bob Sorensen, a senior analyst here at Hyperion Research. I'm going to give you a quick update on what's going around the world in exascale systems, and also give you a little sense of what I'm looking for as SC22 approaches, not from a commercial perspective as much as some of the interesting technology developments that I think are going to become more important in the HPC world as time progresses. Well, let me just give a quick rundown on what's going on near-term U.S. exascale progress. Happily, in June of this year, the Frontier System, Department of Energy, Oak Ridge National Labs, achieved its #1 position by hitting about 1.1 exaflops on LINPACK. The machine has a peak performance of about 1.68 exaflops. Only used, and I can't believe I used the phrase only, 21 megawatts to run LINPACK, which is actually a relatively impressive power performance metric. So hats off to the designers there for doing that. The system is based on Cray Shasta with AMD CPUs and GPUs, and they're looking at full user operations by January of next year. There may be some delay, but that's the price you pay when you push the state of the art for a high performance system like this. It's not a COTS machine, and delay should be expected if not tolerated every step of the way. The next two systems that DOE will be procuring, the next two big exascale systems to be installed in the US is the Aurora system bound for Argonne National Lab. That's a 60 megawatt system, but it's a very aggressive design, and we're all anxiously waiting to see how that turns out. And the El Capitan system going into Lawrence Livermore National Lab sometime in 2023. Just to give you an official situation on what's happening on China's exascale, this is what was announced in 2018 in terms of Chinese activities in exascale. These were the prototype systems that were developed. These were kind of the goals that they had laid out. Very interesting. Sunway, Taihan E3, Shugan systems, all different architectures. That's what happened in 2018. But really, what's happened since then has kind of changed in fact, driven more by political machinations than any kind of technological implications. The reality, or I guess the unofficial reality of what's going on in China right now is the Sunway Pro Ocean Light system has been up and running since March 2021. The Tian E3 has been up and running since perhaps late last year. So in theory, there may be two systems in China right now that have actually achieved exascale capability. We haven't heard too much about Shugan. We think there's some potential delays going on there. The bottom line here is that China has not done any official announcements. They have not made any entries on the June 2021, November 2021, June 22nd list, and they may not do this time around either. This is primarily, we believe, a political decision not to do anything that would further increase U.S. China high tech trade friction. There's been some interesting developments of late with U.S. export controls and some concerns within the basically defense community, Chinese access to leading edge technology. And what this has done is caused China to really drive their indigenous capability a little bit harder. And so no one wants to fan the flames there, I think, by bringing Chinese systems out on the top 500 list. But we know that there's pretty strong evidence that says there could at least be 5 other Chinese systems that could make the top 10 list today, 7 out of 10. But again, we have no official confirmation of that. The EU plans going forward, there's definitely plans for exascale systems in the 2021 to 2024 timeframe. The two key points about Europe right now is that one of the exascale systems is really most likely going to have European technology, specifically using a European processor initiative developed processor. And not only that, but there'll be some additional procurements from the national programs, most likely in Germany, maybe some things in France as well. But the other point I want to make is that Europe, perhaps much more than the United States, is very interested in running their HPC exascale environment in a way that dovetails nicely with their vision for quantum computing. It's a much more integrated program, and as you see here, that basically their plans going forward in the post exascale environment is to really think about hybrid classical quantum systems as a way to achieve the potential high performance. I think that's a really interesting aspect of what's going on in the EU from their perspective. So after that quick look, I just want to give a quick overview here about what I'll be looking for at SC22. I think I'm recording this a week or two before, but I just wanted to give you a sense of some of the technology things that I think are going to be important, start to really be discussed at SC and going forward. First off, I want to say I think mixed precision is going to become a much more interesting development. And this is not just for AI. This is not just for the machine learning, deep learning, integer valued systems. I think mixed precision is going to become much more prevalent, much more of a performance accelerated in the traditional mod sim world. And I'm looking forward to organizations and architectures and software that starts to take care or at least take advantage of the fact that mixed precision does offer some significant performance advantages in traditional mod sim. Look for that. I think again, the hybrid quantum classical efforts are going to be very interesting development here. The HPC world is integral to the success of quantum, and frankly, I think quantum is integral to the continued performance advancement of HPC. So I think that the merging of those two technologies is something that we really need to watch and nurture and hope that it can achieve its best potential. I'm looking interesting on what's happening next on post exascale architectures. I talked about some of the large systems that are going into the US, and part of me believes that the trajectory of bigger, more expensive, more powerful, longer lead time kinds of HPCs that we've seen in the past may have reached an evolutionary endpoint. We're here at Hyperion Research looking at trends more towards smaller systems, much more workload specific, HPC architectures geared towards solving a specific class of workloads with their unique architectural requirements. So instead of buying one big machine that can serve perhaps a wide range of applications, you'll be buying a series of smaller systems that are more efficient, that are better targeted, that are cheaper, and perhaps more energy efficient for the specific workloads at hand. So I'm looking for this kind of workload specific architectures to become the sine qua non of post exascale architectures. I also think that liquid cooling is going to become, again, a requirement. It's going to happen either fast and furious, or it's going to happen without raising any eyebrows, but it's definitely going to happen. And I think that's a really cool trend to watch. And finally, I'd like to see the end of. I'd like to see the end of discussions of Moore's law, the end of Dennard scaling, the end of frequency concerns, all the ends of scaling in terms of process nodes, and really start to think about what are some of the engineering solutions that are going to be out there to meet the specter of end of, and really drive computing capability forward as it always has by finding new solutions and new ways to drive performance. When one roadblock gets thrown up, let the engineers find another way to beat it. And I'm looking for, again, the next turn of the crank when it comes to where HPC performance is going to be coming from. Spoiler alert, it may be quantum, it may be something else. But there's definitely a lot of stuff going on. Well, that's it. I'll stop there. I want to thank you for listening. Thank you for attending our briefing. And if you have any questions along the way, I'll be at SC22. Stop me, grab me. Let's have a discussion. Otherwise, have a good day, and we'll talk to you soon.